Welcome to LeetCode Solver. Today we are going to solve 16th problem in May LeetCoding challenge, and the problem name is odd even linked list. Given a singly linked list, group all odd nodes together followed by even nodes. Please note here we are talking about the node number and not the value in the nodes. You should try to do it in place. The program should run big O of 1 complex space complexity and big O of nodes time complexity. Well, input is 1, 2, 3, 4, 5 null. Then let me guess 1, 3, 5, then 2 and 4. 1, 3, 5, 2 and 4, and finally null. Let me guess here 2, 3, 6, 7, and 1, 2, 3, 6, 7, and 1, 5, and 4. Then after null. And note the relative order inside both the even and odd groups should remain as it was in the input. Okay, relative order should be same. The first node is the considered odd, second node even, and so on. Odd, even, so on. The first. Okay, so let's think with this. First one is this, then after I need to have this one. Okay, what I can do, I can simply delete it from here and attach in front of 2. Okay, then what will happen, 2 and 3, and then after 1, 5, and same thing, because I deleted 3 from here and attach it to front of 2. Now when I go to another odd index, 5 is fine, 6 is another odd index. If we go for indexing, 1th index, 2nd index, 3rd index, 4th index, 3rd index, what? 3rd index, 4th index, 5 index, 6th index, 7th index. There is something problem with this spacing, I don't know why. When I click 2 times, it will automatically create dot sign, I don't know why. So when I reach to 6, I do the same thing, like I just delete it from here and I'll attach in front of not 2 but 3. So it will become 2, 3, 6, 1 is still there, and 5, after 5 I have 4 is deleted. Oh no, 6 is deleted. I have link with 4. Nice. Then when I reach to 7, then this is also odd index. Then I will just erase it. If I erase it, then what happens? It will link to null. And after erasing, I will just append in front of 6. So 6 and its next element is 1. Finally, I have a solution. So I can do this. So whenever I reach to, the logic is simple. Whenever I reach to some odd index, then I will delete it from there. Like in order to delete it, I need to have information of my previous node. So need to have previous list node, and if I have previous list node, then I can just attach previous list nodes next to its next position so that it will be deleted. And in order to attach in front of what, in front of firstly in front of the current mm, odd, maybe this is odd position, first odd position, and I will attach in front of that odd position to the deleted element, and the deleted element which I attach will be come now next odd's last element. So I have to attach to the odd's last elements, odd's last node, insert in between odd's last node, and what I will doing insert odd last node and even's first node, and after insertion I will update my odd's last node. Okay, after updating odd's last node, then next time I will do the same thing while insertion. This is while deletion. I need to have a previous list node which will link to parents next node in case of deletion. Well, let's go for coding then. So if we do this, we can just we don't need any extra space. We can just solve it by iterating one times, which will result into big of n complexity, time complexity, and space complexity is constant. Let's do it. As I mentioned, list node. Let's hold a list node in a pointer that we gonna use to iterate it. Okay, before that, let's find the case when, like, say for example, if the given head itself is a null linked list, or maybe the first element is the second element is null. If any one of them is null, then I don't have to maintain anything, return as it is. Otherwise I will have at least two elements. And let's use ptr for traversing, and list node, as I mentioned before, last we need last odd node. Say last odd will be equal to head, basically in the beginning, and list node first even. We also need first even because we gonna insert in between last odd node and first even node. So first even is head next. Now what else we need? We need previous. So I'm thinking to start my traversal from next node. ptr will be now head next. ptr is not equals to null. Now I need to know if it is odd position, then I need to do that. So position index, first index is already skipped. This is the second index, and yeah, or maybe position instead of pos index, it is one west indexing. So position, or say index, just index. If index modulus 2 is 1, if it is odd, then we're gonna make these changes like deletion. Let's focus on deletion. Deletion will be just simple. Previous node will be attached to previous next will be attached to current value. which is found in ptr. Current values, next. Deletion, insertion in between. So insertion in between what? Last odd and first even. First even is always constant, not changing. So let's insert. In order to insert, we need to know last odd. Last odd next should be equal to ptr. Now ptr next will be equal to first even. Okay, alright, we are done. Now insertion completed. Deletion completed, insertion completed. Anything left? Every time we have to increase index plus plus. Now let's update our ptr, which will be equal to next node. We need to know next node. So in this case, the ptr, in order to go to the next node, we need to have that information. We already erased this information, so let's put it somewhere. List node, next node will be equal to ptr next, and we can do these changes. Next node, deletion done, insertion also done. Attach from last node, last odd nodes next as ptr, and ptr next as a first one. Now we have to update last odd. So last odd will be equal to last odd is ptr. Now previous, in order to calculate previous, ptr will be simply next node. Previous will be equal to what? ptr. Finally we will return head. Let's compile the code. Problem in line number 35-25. Compilation error, line number 35. What is the compilation issue? First A1. Undeclared first A1. Spelling mistake or what? FIRST, okay. TLE, okay. Something did not break. I mean, while loop didn't break, I guess. PTR is migrating to next node. Next node is PTR next. And if it is even out position, then we're just deleting that. And previous, did we update previous PTR? Okay. Previous next will be equal to next node. That's for sure. And odd last next will be equal to PTR. Sure, PTR next will be first even. Last odd will be update last odd. What? Update last odd. Okay, last odd would be PTR. That's for sure true. PTR next is first even. That's also true. Last odd net is PTR. That's also true. PTR is now becoming next node. That is also true. Everything is true. Previous will be now PTR. That is also true. Okay, head is null or head next is null, then returning head. Otherwise PTR is head next, nice. Last node is head, nice. First even is head next, nice. Previous is head, that's also nice. Index is 2. We have to increase index every time. Next node is PTR next, that's nice. What is odd, then we are doing deletion. Deletion means previous next will be equal to next node. And last odd is initially should be head. Yeah. Last odd next is PTR. Okay, fine. PTR next is now first even. That is also true. And last odd will be equal to PTR. PTR equal to next node. PTR is equal to PTR. Oh, previous is PTR. Then after we will be updating PTR to next node. Okay, alright. Accepted. Thank you so much for watching this video. Hope it helps you. If you have any query, suggestion or any improvement plans, please feel free to comment, like and share, subscribe this channel. Hope to see you in the next video. Till then, have a nice time. Bye bye.